Okay, we've got a series here, and the first thing we want to try to do is to try to get it in a form so that we can see the properties of the geometric series. So you want to know what the common ratio is, and you want to know what the first term is. So let's try to change its form here. The way you do that is you've got n plus 1, and whenever you have n plus 1, you have 3 times 3 to the n. Because remember, this 3 here is to the power of 1, and when you multiply things like this with the same number or the same variable, you add the exponents. So that's the first thing, that this is what we have there, and then this could be brought to the denominator, as in 4 to the n here. Now, we're starting to see some clarity. We're starting to get there. We can notice that we've got two things being taken to the same exponent. And that was our goal, to get the same exponent, because when you have a thing in the numerator and a thing in the denominator to the same exponent, you could just take that exponent out. So now it really looks like a geometric series. You should be able to recognize that that is exactly the form, with this corresponding to a in the case when this goes to 1. But in our case, we have to be very careful. Does this actually go to 1? Does the common ratio, this tends to be a and this tends to be the common ratio. And this is the common ratio, it's r, 3/4. But here we're plugging in 1. We're plugging in 1, and this doesn't have n minus 1, this is just n. So our first term is actually 9/4. Our first term is going to be 9/4 in our series. And our common ratio is 3/4. So this is our initial term, and this is our common ratio. Common ratio is 3/4. And with a geometric series, you check if the absolute value of your common ratio is less than 1. If it is less than 1, then you know that this converges. If it's greater than or equal to 1, then it diverges. Is the absolute value of 3/4 less than 1? Yes. So this converges. This converges. When a series converges, you want to find out what it converges to. It is only in the case when it diverges that, by definition, it's not going to a constant number. But here, it is converging. So the way we find this is by this magical formula, which we have, which is a over 1 minus r. A being your initial term, and r being your common ratio. So we've got 9/4, 1 minus 3/4. And that is actually what it converges to. We can simplify. It's not too difficult. We've got 9/4, and then we've got 1/4 here. The fourths can cancel out, and we're left with 9. That's a 4. That's a 1. So we're left with 9. So that's pretty much it. That's what you need to find out. And this is how you do it. You need to get it into a form where it looks geometric. And so then you could plug in the 1, and you could find your initial term, your common ratios, whatever is being taken to the exponent.